So we are going to soon start the AhaGuru live session on problem types. So warm welcome to the AhaGuru live session on problem types. Today I am going to talk about electric charges and electric fields. Okay, so we are going to look at that. Every week I will be doing one problem type. One problem type doesn't mean one question. I will be doing multiple questions, all JEE questions or NEET questions. Basically I will take these old previous year question papers, look at one problem type and analyze that problem type in great detail. So you will be able to then understand how to solve questions based on that one problem type. Okay, it's time now, let us get started. So I'm going to first, before we start, quickly tell you something which is very, very important and useful. Okay, so let me start by telling you about this. Now, please remember, most people don't know this, that in JEE and NEET, most of the questions that you get, 70% of the questions in JEE and 85% of the questions in NEET, they are easy and medium. Okay, so you have to keep that in mind, that most of the questions that you get in JEE and NEET are going to be easy and medium questions. Okay, this is something that I have analyzed taking the last 20 years of question papers, and you can categorize the questions as very easy, easy, medium, hard, very hard. If you look at very easy, these are just NCERT textbook based questions. Easy questions are not directly lifted from the book, but these are questions where one concept, one formula is all you need, one step you will be able to solve it. Medium questions, these involve two formulas or three formulas, 2-3 steps, 4 steps you will be able to solve that question. Hard questions on the other hand involve very different concepts. Okay, maybe 2 or 3 different concepts and will involve 6 to 8 steps. Okay, so it will be reasonably tricky. And very hard, only JEE Advanced will generally ask this. JEE Mains will have very few of these. Multi-topic intense calculation, maybe integration based, right? So these are very hard. And if you look at boards, 20% very easy, 30% easy, 40% medium, 10% hard. Every exam has a mix of medium, easy, medium, hard. If you take NEET, 10% very easy, 30% easy, 45% medium. It also has some hard, 15%. But if you look at these three together, 10 plus 30 plus 45, what do you get? 85%. So 85% questions that appear in NEET exams year after year after year, they are easy, medium questions. If you take JEE Mains, they don't give you very easy direct lift off from the book. That question type of question won't be there. But you will get single concept, single formula, 1 step, 2 step kind of questions, 30% questions. And 40% questions are medium level. 20% questions are hard, 10% very hard. So if you add this up, 30%, but just look at this, 70% questions in JEE Mains are easy and medium. Similarly, if you take the JEE Advanced, 20 plus 30, it has more of the very hard and hard, but if you look at these two together, it is 50%. So please remember, 70% of JEE Mains is going to be easy and medium. But what happens is most students don't get these questions correctly in the exam. Why? It's easy, no, they should get it. The problem is they spend a lot of time practicing hard questions. And the assumption is if you do a lot of hard questions, somehow the easy questions you can automatically get. No, you have to practice these separately. Each question type you have to practice. There are easy question types, there are hard question types. Don't keep on practicing only the hard. Also spend enough time. First you have to master the easy and the medium, then you can worry about the hard. So do that, and that way you will make sure that you have all the question types on your fingertips. Okay, let us move on. So today's session, I'm going to take one question type. There are 2 variations to this question type, but I'm going to take one very important question type that comes up in JEE and NEET. Okay, both JEE and NEET. In JEE you get a lot of these. NEET also you get quite a bit of this. Okay, so this is going to be on electric charge and field, and the question is, you have a charged pendulum bob kept in an electric field or kept in the presence of another charge, and because of that the pendulum is going to swing and come to rest somewhere at some angle. We are going to try and see how to solve such questions. Okay, I'll just show you first. Before I get to solving, I'm going to show you, look at this question. This is one type of variation. Suspended pendulum bob, electric field. Notice JEE 2025, JEE 2024, JEE 2019. Okay, and of course JEE 2010, JEE 29. Almost every year this has come. Look at this question. There is an electric field. There's a charged particle of mass 2 grams suspended through a silk thread, etc. We will do this question in more detail. It remains stationary at a distance of 10 centimeters from the wall. If the charge is so much, find x. Think about this question. And think about this question. Same question. Here they have told you the electric field. Here they have not given you the electric field. Here in 2025, what they asked you, they have told you that there is a small bob, okay, which has some charge, and it is connected to an insulating thread. The same kind of question as 2024, but instead of telling you the electric field, they have said that it is brought near an infinitely long non-conducting sheet. What will an infinitely long non-conducting sheet of charge density sigma, what will it do? It will produce an electric field. So here the only difference is that there is a sheet producing the electric field. This sheet produces an electric field. They have not given you the electric field. There they gave you the electric field, here they give you a sheet. That's all. That is the only difference. And if you look at this question, 2019 question, the bob of a simple pendulum has mass 2 grams, etc., etc. Same question. There is a horizontal electric field of intensity so much. The difference is in numbers. If you look at this question and this question, ditto. This question is also the same. In all the questions, you have a horizontal electric field which makes this bob swing to this position. So how to solve this question? I'm going to show you. I'm going to go one by one with each of these questions. I want you to keep in mind that all these three questions are actually the same type. Not only these three, one variation where electric field is basically being given. I'll show you three more questions. Now if you look at these three, looks very similar to that previous one, except now you have to use Coulomb's law. That's all, extra. Okay, it's also the same type with a slight variation. So JEE 2021, two small spheres, each of mass 10 milligrams, are suspended from a point, etc., etc. You can see that you have this kind of idea. There are two bobs, right, and connected to a string, and so the string is going to go like that because of the electrostatic repulsion. And the question is, find basically the charge on the spheres. The charge on the spheres. Don't worry about the fact it is written as A by 21. That we will, when we look at the question, we will look at it. It's an integer type question. Find the integer nearest to A. Look at this JEE 2022. Here, there is a slight variation. There are three of these charges, and they are basically hung from that one point. Instead of two, it's a small variation where now there are three of these, so it will form like a tetrahedron. Okay? 2010, this is an interesting variation. Same type of question as this one, exactly the same. You have two basically charged spheres, identical spheres, and they're going to go like that, right? They're going to form a shape like that, except now it's also being placed in a liquid. I will solve this question and I will show you how to apply this how to look at a variation like this. So we will look at these questions one by one. So I'll start with the first question. So in these sessions, what I'm going to do is I'm going to show you that one question type gets repeated again and again in JEE and NEET. I'll take that question type and I will analyze one by one each of those questions, and I'll show you. I won't solve all of them. I'll solve most of them, and I will give you a couple of them as homework. Okay? So that way, the idea of this whole session is that you will become super thorough with this one type. Is it going to be useful for JEE? Of course it's going to be. Once you go through this, you will know how to solve this kind of question thoroughly. Okay? Now, before we start, I'm going to show you two different approaches to solving questions involving charged pendulums. Okay, two different approaches. So there is an electric field. So let me start with the basic idea. There is a charged bob, of course tied to a string. It is basically held there. And there is an electric field. There is an electric field acting like this, let's say. We'll assume there is a positive charge. It's a negative charge. It will basically swing in this direction. No big deal. Now, this is going to feel a force QE. You know that if there's an electric field, uniform electric field, it's going to feel a force QE. But not just that, no, there's going to be a force, gravitational force, mg. And then there's going to be a tension which is going to act like this. Right? Basically, because actually if the QE was not there, this would have been hanging like this, right, vertically down. And because there is a QE, it starts to swing that way. It will do some oscillations and finally it will come to rest there. So that's what we have. How do we solve a problem like this usually? Okay, so I will show you. So first we say, okay, this angle is theta, so let me draw this vertical line, and so then I know that this angle, these two are vertical, so this angle must be theta. You know that. Then we say, okay, t, let me resolve t this way and this way. So if I resolve t like this, it will become t cos theta. T cos theta. And then this component of t will be t sin theta. This is the standard approach. So now you don't need the t. It's a good idea to cut it out because you have got these two components, right? You don't have just all. This component is equal to the t. Okay, now what do you say? This q is in equilibrium. So net vertical force must be 0, net horizontal force must be 0. And so t sin theta must be equal to QE. T sin theta must be equal to QE. Right? The horizontal forces must cancel. T cos theta must be equal to mg. T cos theta must be equal to mg. Now, then what do? We have to solve. Now, if you want to solve for t, right, you can square this and add. Sin square theta plus cos square theta will be 1. So you'll get t square is equal to QE whole square plus mg whole square. I'm not interested in that. I'm interested in knowing something about theta. See, if you divide this by this, right, the t will cancel. Then you will get tan theta is QE by mg. Now, of course, from this, if you want theta, you can find. If you know Q, E, M and G, of course you can find. G you know, M you know. So if you know Q and D, you can easily find tan theta, so you can find theta. Or sometimes they'll give you theta. They'll say, oh, it has gone to this particular angle. So that means you know tan theta, you know mg. Using that, you can either find Q if E is given, or you can find E if Q is given. Okay. So but basically this is the main equation. If you want, you can also say t square is equal to QE square plus mg square, etc. You can do many more things with it. But the broad picture is this is how we usually solve, by resolving, writing two equations, etc., etc. But I'm going to, because this question comes so many times, of course you can solve it like this. If you're very comfortable with this, go with this. But today what I'm going to do is I'm going to first tell you one nice trick. And why such a trick is important? Because this question comes up again and again and again. It will come in your board exams, it will come in NEET, it will come in JEE, it will come in BITSAT, it will come in every exam. Because this kind of question will get repeated. You know that if you have three forces adding up to 0, right? The net force is 0. That means the three forces, right? Suppose I had one force, second force, third force. If you want it to add up to 0, they must form a nice triangle. And that's what I'm going to show you here. So you have mg, like that. Okay. Actually, let me do one nice thing. Let me use arrow here so that way it looks a little neater. So this is mg, right? This is mg. Okay. So let me write mg. Now remember, you have a QE there, right? But if I bring it to this, I can do vector addition. So what I'm going to do is I'm going to write QE here. This is QE. QE. And then T. But if I go from here to there, it should come back to the starting point. Why? Sum of these three forces must be 0. It is an equilibrium. So let me take this and join T this way. Okay, so that's how T must be, so that you get a nice right angle triangle. Why? This is vertical, that is horizontal. This is 90 degrees. Right angle triangle. And remember, this T is along the rope. So if this angle is theta with the vertical, this angle is theta. So you've got a nice forced triangle. So I call this method forced triangle method. So you draw a forced triangle, simple. So mg plus qe plus t must be 0. That's what you're writing there also. Except we are resolving and finding it. Here we are doing it in very simple geometrical way. What is the advantage? Now this is a right angle triangle. So this side by this side is tan theta. So straight away I can write tan theta is QE by mg. Finished. No equations. Okay, this is very powerful. I'll be using this all the time. I will draw this forced triangle. Once you get used to it, you will never go back to this. Trust me, just try it. Right? In the beginning you may find it, oh, I already know that well, this I don't know. But you will start with this, you will realize that this is much, much simpler, reduces problem solving time dramatically. Okay. What about if I want t? No big problem. mg by t, what will that be? Adjacent side by hypotenuse, cos theta. So t cos theta is mg, which is what I wrote there, no? Similarly, QE by t will be sin theta. If you want, you can write that. Okay. And if you want to find t, you can say this square plus this square is t square. So t equal to root of mg whole square plus QE whole square. That's it. So directly using right angle triangle, you can solve. We won't need all that. This is what we will need. And so I'm always going to draw this kind of a forced triangle to solve questions. So I hope this is clear. Okay, let us now move on to the first question. Before that, let me quickly look at comments. Very good. So UNT, I hope you are able to follow things. Okay, very good. This is the class. Yeah. Can't we use Lamy's theorem? So basically, the myth. Okay, that's your name. Okay, Lamy's theorem. Of course, you can use Lamy's theorem, but this is so much simpler. It is a right angle triangle. Why will you waste your time going into Lamy's theorem? If you have three different forces at weird angles, Lamy's theorem makes sense, but now you don't really need to do that. Okay, so let us go on. Yeah, let us go on. Right? So let us start looking at this question that appeared in the JEE in 2024. A charged wall provides a uniform electric field of how much? 2 into 10 to the power of 4 newtons per coulomb. I'll first right now just call it E. So let us say that there's an electric field E acting like that. Okay, normally, so acting like that, horizontal. A charged particle of mass 2 grams, please remember 2 grams you have to convert into SI units, kilograms, is suspended through a silk thread of length 20 centimeters, remains stationary at a distance of 10 centimeters. So this distance is given. This distance is how much? 10 centimeters. Always draw a diagram and mark all the information on the diagram. That way the problem solving gets easier. I have used this information there. The charge on the particle is 1 by root x microcoulomb. Why will they give you 1 by root x? Oh, because they want you to give an integer answer, right? Usually when they give it like this, that x will turn out to be a nice integer because you have to enter an integer in the JEE. It's an online test, so they'll expect you to enter the answer. Anyway, so how do we solve this problem? No issues. We have already seen what to do. There is going to be a force mg. This is mg. There's going to be a force QE. And there's going to be a force tension, right? The tension force is going to be like that. And these three forces are going to add up to 0. So they have to come back like that. So this is mg. This is QE. And this is T. And if this angle is theta, this angle is theta. Why? Vertical, this is the incline, vertical, same incline. No, tension acts along the rope. Okay, so QE by mg equal to tan theta. Do I know tan theta? Tan theta, theta is not given. Oh, but look at this. Look at this right angle triangle. Opposite side, 10. Hypotenuse, 20. So what is sin theta? 10 by 20, which is half. Sine of what will be half? Sine of 30 degrees. So theta has to be 30 degrees. So what is tan 30 degrees? Tan theta is tan of 30 degrees 1 by root 3. So you know tan 30, 1 by root 3. Okay, so tan theta is QE by mg. Tan theta which is 1 by root 3 is, right, QE by mg. What do I want? I want the charge. That means I want Q. So Q will be mg, right, divided by E root 3. So Q, first I use variables and then finally I'll substitute values, because values will look like this, no? So when you substitute, you will make mistakes. So use variables as much as possible. So Q equal to mg by E root 3 or root 3E. Now I'm going to plug in the values. What is m? Mass. 2 grams. 2 grams. Now grams means you have to convert to kilograms. 2 into 10 to the power of minus 3. Please remember, grams you have to convert to kilograms. Milligrams also you have to convert to kilograms. Always convert to kilograms. Kilogram is SI units. G is given 10. So we use 10 mg divided by root 3 times E. Root 3 times E. What is E? E is this. 2 into 10 to the power of 4. Is it in SI units, newtons per coulomb? Yeah, it is. So 2 into 10 power 4. So 2 we can cancel. This is 10 power minus 2. 10 power 4 goes, it will become 10 power minus 6. So Q is 1 by root 3 into 10 power minus 6 coulombs. SI units coulombs. 10 power minus 6 coulomb is a microcoulomb. So 1 by root 3 microcoulomb. We have been told the charge is 1 by root x microcoulomb. So 1 by root x has to be 1 by root 3. So what should x be? So x has to be equal to 3. Right? 1 by root x is 1 by root 3. So x has to be equal to 3. So find the value of x was the question. So the answer is x is 3. Basically you have found Q. Q is 1 by root 3 microcoulomb. So is that clear to everybody? Okay? Quickly. Everybody is clear about this? If you are clear, just post on the live chat. Just simply say yes or say aha. Okay, if you have understood it. Come on. One common doubt. Rupa Harini has asked, sir, one common doubt for electric field. Sometimes we resolve components to solve. Sometimes we use resultant. How to know which approach? You can use both. Here also you can resolve, right? But if you resolve here, what will happen is that, not for the electric field, if you're looking at forces here, if you resolve, you can solve it, except it gets a little longer, that's all. And once you write a lot of equations, you'll get kind of stuck in the equations, no? You have to sit down and solve. Whereas here, directly you have tan theta is QE by mg, you are just simply finding tan theta, that's it. The rest of it is very straightforward, right? So, okay, very good. I can see a lot of you have answered. Very good, excellent. Okay. Venkata Krishnan, I will be doing this every Tuesday from 8 to 8:30, half an hour. I know we are running a little bit out of time, but we will try and finish as much as we can. Let us move on to the next question. Okay, so here, this appeared in the JEE in 2025, JEE 2025. A small bob of mass 100 milligrams and charge 10 microcoulomb, plus 10 microcoulomb, is connected to an insulating string of length 1 meter. So I have drawn the diagram there. It is brought near an infinitely long conducting sheet. This is a huge conducting sheet. Now what will be the electric field produced by the conducting sheet? In that direction, right? What will it be? Sigma by 2 epsilon naught. Okay? So once you understand Gauss law, you realize that this is the answer. This is one of the first problems that you solve with Gauss law. So you have an infinite sheet of charge. The electric field produced by that infinite sheet is sigma by 2 epsilon naught. Now you have to use that in combination with this question, right? So if I look at this, right? So here I have this bob, and you know that this is going to be mg force here. You know that this force is going to be QE. E is going to be this, QE. And this is going to be T. Same question, no difference. Only difference will be the electric field is sigma by 2 epsilon naught. That's all the extra thing that they've given, right? So if you look at this, right, the string subtends an angle of 45 degrees at equilibrium. So you know that this is in equilibrium. That's why I'm basically drawing the force triangle. Tan theta is QE by mg. That we can just draw this diagram. We'll immediately see tan theta is QE by mg, right? Okay. But E is sigma by 2 epsilon naught. So that is what you have to use here. The only extra is this. This is the only extra piece. Otherwise, you already know everything. QE by mg equal to tan theta. And what is tan theta? Tan 45. Tan 45 is 1. So tan theta, which is tan 45 degrees, is 1, and this is QE by mg. Okay, and E is sigma by 2 epsilon naught. So I can just substitute that, right? So Q sigma by 2 epsilon naught mg. That is equal to 1. What is the question? The question is find sigma. Find sigma. Well, sigma, okay, sigma, bring this up there, 2 times epsilon naught mg by q, right? Okay, 2 times epsilon naught is given 8.85 10 to the power of minus 12. So 2 times 8.85 into 10 power minus 12. What about m? What is the mass? Mass is 100 milligrams. Now this is where you have to be careful. Milligrams to grams is 10 power minus 3. But grams is not SI units. Kilogram is SI units. So milligram to kilogram is 10 power minus 6. Please remember, 1 milligram is 10 power minus 3 grams, which is 10 power minus 6 kilograms, and that is the SI unit. So 100 milligram will be 100 into 10 power minus 6. 100 into 10 power minus 6. That is without the G. G also you have to separately put, no, that is 10. Divided by Q. Q is given 10 microcoulomb. 10 microcoulomb, 10 into 10 power minus 6. Of course, the rest of it we just have to cancel. This and this we can cancel. This 10 and this 10 I'm going to cancel. So this is going to give me 10 to the power of minus 10. This is going to give 17.7. This is 17.7, 10 power minus 10. 17.7 into 10 power minus 10 SI units, coulomb per meter square. Coulomb per meter square. Now 10 power minus 9 is a nanometer. So if I take 10 power minus 1, put it here, I will end up getting 1.77 nanocoulomb per meter square. Is there an option? 1.77 nanocoulomb per meter square. So that is the correct answer to this question. I hope you have understood, right? Same principle. Mg QET triangle. That's it. Very, very straightforward. So next question, I will quickly show you the next question. Okay, I'm not going to solve it. So this is homework because we are almost running out of time. So if you look at this question, again JEE 2019. So if you look at this, a bob of a simple pendulum has mass 2 grams, charge 5 microcoulomb. It is at rest in a uniform horizontal electric field. The electric field is given, horizontal, intensity is given, so E is given. At equilibrium, find the angle the pendulum makes with the vertical. Right now they are asking you the angle. You already know it. This. Right, you know what to write there, and with that you can actually find the angle. So very, very simple, straightforward. I'm not doing it anymore. This is homework. Okay, now I've done 3 questions of one type using electric field.